All right, welcome back, 8th graders. So now we're on to multi-step equations. We're going to continue on with our expanding it by saying why we can do each step that we do in those 2-column proofs. And here we go. So when we go to multi-step equations, this is where we have to start combining like terms or distributive property, that type of stuff. So here we have our first problem. I see that I have a 5m and a 2m, and so my first step, and here's our proof, our reasons. So here's our given. Our first step is that we're going to combine like terms. I call that CLT, combine like terms. Now, combine like terms only happens on the same side of the equal sign. I want to point that out. Combine like terms is when we have an expression that we're simplifying it on one side of the equal sign before we move things over. So I'm going to copy down my 5 equals, and then 5m plus 2m is 7m, and then I keep the minus 23. All right, and then as we're doing equations, even though we call this minus 23, think of it as negative 23. And so whatever your sign is in front of your number, that stays with the number, and that is very important. Don't go moving numbers around and changing the sign in front of them, because then you change the value of the equation. From here, it's now just a 2-step equation, and so since this is minus 23, I'm now going to add 23 to both sides. So plus 23 plus 23, and so in order to do that, that is our addition property of equality, so APOE allows us to do that, and 5 plus 23 is 28. So I end up with 28 equals 7m.
Nathan, come here.
And then I divide both sides by 7. And so since I'm dividing, that's going to be the division property of equality. And so 28 divided by 7 is 4. And so m equals 4. And if I'm not sure, then I can take 5 times, ooh, that's a terrible looking 5. 5 times 4 minus 23 plus 2 times 4. And so 5 times 4 is 20 minus 23 plus 8. I'm going to do 20 plus 8 to get 28, and then minus 23. And then 28 minus 23 is 5. And that's what the left equals the right, and therefore this is a correct. I've just checked my answer and I got the correct answer. All right, so now we've got our word problem here. Martha takes her niece and nephew to a concert. She buys t-shirts and bumper stickers for them. The bumper stickers cost $1 each. Martha's niece wants 1 shirt and 1 bumper and 4 bumper stickers, and her nephew wants 2 shirts but no bumper stickers. So if Martha's total is $67, what is the cost of 1 shirt? So I don't know what t-shirts cost. So my shirts I'm going to call X. And then I know that for each bumper sticker, it is $1 each. So no matter how many bumper stickers, that's just how much each of those were. And our total is $67. We know that the niece bought 1 shirt, and the nephew wants 2 shirts. And those are the things we don't know the price of. So we know that the niece wants 1 shirt, and we don't know the price of that shirt, plus the $4 worth of bumper stickers, because she wants 4 bumper stickers. And we know that the nephew wants 2 shirts, no bumper stickers, and that our total is $67. So that's our equation. When we write our proof with it, we can just say word problem. Right? That's where we got the equation. It's from the word problem. From here, x plus 2x is going to be 3x plus 4 equals 67. So here we combined like terms. And then from here, I'm going to solve. So I'm going to use the subtraction property of equality, and I'm going to subtract 4 equally from both sides. So then I get 3x equals 63. And then I'm going to use the division property of equality. I'm going to divide both sides by 3 so that x equals 21. And so each shirt is $21. And that's our answer. And if we're not quite sure, we just plug it back in and make sure that we end up with 67 on both sides of the equal sign. All right. So here we are. Next problem. So this would be our distributive property is what we're going to use. So we're going to start off by saying that I was given this equation. I'm going to distribute the negative 8. So negative 8 times 2 is a negative 16x. Negative 8 times negative 1 is a positive 8, and that equals 36. And so that was the distributive. Distribute. You can just go with distribute or dist, or, the fact that we're distributing, distribute. Now, from here, two-step equation. So I'm going to subtract 8 from both sides, so that's going to be the subtraction property of equality. So I'm going to end up with negative 16x equals, and then 36 minus 8 is 28. And then I'm going to divide both sides by a negative 16. So positive divided by negative is going to give me a negative answer. We are using the division property of equality to get this. And 28 divided by 16 doesn't happen equally. And so we have 28 sixteenths, and then I simplify that. So 4 goes into both, so I get a negative 7 fourths. So that's what x equals, is a negative 7 fourths, and that's our answer. And if I'm not quite sure, then I plug it in, and I check to make sure that that's what I get on both sides of the equal sign. All right. Now, this one does not look like a distributive property problem, but we're going to treat it like a distributive property problem. No one likes fractions. I don't even like to work with fractions if I can avoid it. And so the best way when working with equations to get rid of fractions is to use, write my given here, to use the multiplication property of equality, and I'm going to multiply by the LCD. Multiply by the LCD, and that will get rid of my fractions. So 4 and 3 LCD is 12. So we're going to multiply both sides by 12. And so I'm going to take 12, and this is where distributive property comes in. 12 times 3/4, so 4 goes into 12 3 times, and so 3 times 3 is 9, so now I have 9x minus, and then I'm going to take 12 times 1/3, because there's that invisible 1. 3 goes into 12 4 times 1 is 4. So 9x minus 4x equals 120. That looks more like something I would rather work with. And so I got that by using the multiplication property of equality, and technically we distributed in that process. Now I'm going to combine like terms, and 9x minus 4x is 5x. So 5x equals 120. And then from here, we use that division property of equality, divide both sides by 5, and x will equal 24. And that's our answer. And so I use the multiplication property of equality with the distributive property to get rid of fractions. And what we do to one side, we have to do equally to the other side. So that's why it's the multiplication property of equality and not just distributive property. But in this way, we've gotten rid of our fractions, and we're working with whole numbers, and we don't have to worry about like term or like denominators, etc. All right, so example 10, I can do the same thing with decimals. I just multiply by the power of 10. That is the number of decimals I have. So yes, this is 1, but our biggest number of decimals is 2. And so I'm going to multiply everything by 100 because it has 2 zeros and it moves my decimal place 2 times. So I'm given using that multiplication property of equality along with our distributive. Then I'm now going to distribute that 100. So 100 times 3.5 is going to be 350 minus, I move this 2, 1, 2, and I end up with 2x equals 124. So now I'm working with all whole numbers, making it easier. I'm not having to do any decimal points. Now I just have to solve like I would normally. So I'm going to use the subtraction property of equality because this is a positive 350 and I want to make this 0 on the left side. And so now I've got a negative 2x. Do not drop that negative sign. This is where most students make their first mistake. Do not drop that negative sign. It comes with the 2x. And then 124 minus 350 is going to be 200 negative, because the 350 is bigger, negative 226. From here, we're going to use that division property of equality, DPOE, and we are going to divide both sides by negative 2. And so then our negative divided by a negative becomes positive, and 226 divided by 2 is 113. And that's my answer. And I could get rid of the decimals so that I'm not working with decimals. I can just work with whole numbers. And in my opinion, that's easier to work with, but we each have our own. If you wanted to work with decimals, you could. But that's using the distributive property in order to solve decimals and or fractions. Until next time when we start working on variables with both sides of the equal sign.